Hello students, so today I want to explain about this electronics, basic electronics and this what is atomic structure and Bohr's atomic model. So basically what is electronics? Electronics is nothing but it's a branch of engineering which deals with current conduction through a vacuum or gas or semiconductor. So that means it's a branch of engineering in which the flow of electrons, basically in the olden days, 1947, before invention of transistor, we used vacuum tubes. Okay, so the flow of electrons, how the electrons are flowing in in this uh, vacuum tubes and semiconductors, that is known as electronics. Electronics that is essentially deal with electronic devices and their utilization. So that means from the day one onwards, nowadays we are using your electronic devices like AC, refrigerator, and how household applications and basically office related applications, printer, scanner, and your laptop, your mobile phone. So from day one onwards, you are using these electronic devices. So in this electronic devices, how the current is flowing, okay, and how the current is flowing and their properties, okay, which uh, enables them to function as a behave as a friend of man tool, okay. So that means that is user friendly. So whatever the electronic devices we are using, those are user friendly, okay. So importance of electronics. So where you are using, there are nothing but some applications of electronics. Where you use these applications of electronics like rectification. So rectification is nothing but conversion of AC to DC called rectification. Like in power supplies, we have seen like if you want to convert whatever the AC signal into DC signal, so you need to give it to the step down transformer, and after that you need to use some half-wave rectifier, full-wave rectifier, or bridge rectifier. There it will convert AC to pulsating DC, and you are giving it to some filters. It will remove the ripples, and whatever the voltage you want, you can give it to the regulator. So the suppose if you want 5 volts DC 5 volts DC voltage, you can give it to this regulator. You will get a 5 volts DC supply. Okay. So it means nowadays we are using this DC voltage in charging related, like you have like electrical EV vehicles. So there we need to charge the batteries. So how we what we are using? So we are using DC voltage for charging those batteries. So there is a need to convert whatever the AC signal into DC signal. So in our household, you are getting AC. You know, like 250 volts and 50 hertz you are getting. So that you need to convert AC to DC. And next application is amplification. So amplification is nothing but to strengthen the signal. Like you want to strengthen weak signal into strong signal. Like example, suppose any speaker he is speaking in any big auditorium. There, there thousands of people are there. So directly speaking means all the audience can't listen. Okay. So there the sound signals, what are the physical quantities that is given to the microphone. So microphone will convert physical quantity into electrical quantity. That is a weak signal. So that weak signal you need to give it to amplifier. Amplifier will convert weak signal into strong signal. And again, you can give it to loudspeaker. So that loudspeaker will convert whatever the sound signal, weak signal, that amplified signal into sound signal. So there, most of the transistors like BJT and FET, we can use as a amplifier. So to amplification purpose, we can use this electronics and control of electronic devices like automatic control, like the wash, controlling like automatic washing machine, or if you want to control like automatic robotic arm. Okay, there we can use automatic control. And generation is what it is used to convert DC power into AC power. So for DC generators, we can use this generation purpose. Okay, like oscillators also, it will generate the DC power into AC power, and we can use for conversion of light into electricity. Like suppose wherever light into electricity means, example, you can say like solar panels are there. Solar panels there we are using that light energy, we are converting into electrical energy and we are giving to some electronic circuits so that we can generate the electricity. And we can use from electricity, that means electricity into light. Like nowadays, LED bulbs are coming and light emitting devices, LED, the uh, basic device which will convert electricity into light is LED, light emitting diode. So LED we can use in like indication purpose in the power supply, like any device is there. Suppose if you are making charging, okay, so that shows that indication purpose that your device is working properly. Or like we can use in television that will convert. So you are getting the light in CRT or LED displays, okay, and radars also. So we are using this conversion of electricity into light. So these are some applications of electronics. So basically, we'll see about the atomic structure. So before going to semiconductor physics, we'll go into the atomic structure, the basic scratch level. Okay. So so according to modern theory, matter is electrical in nature. All the matters are in electrical nature. So those are composed of small particles. What are those particles? Atoms. So every matter is made up of small particles. Those are nothing but atoms. Okay. So we can say that the atom is a building block of all matters. So what will be there in the atom? So atom consists of a nucleus. Okay, in that nucleus is positive. So in the nucleus there will be two particles will be there. One is proton and neutron. Proton is nothing but a positive charged particle, and neutron is not having any charge. So in that nucleus, electron will be revolve around the nucleus. Okay, so nucleus is a central part, okay, that contains protons and neutrons. So need to know about atomic weight and atomic number. So atomic weight is nothing but what? Number of protons plus number of neutrons gives the atomic number. So the extra nucleus, that is outermost part that contains electrons. Okay. So if you see, this is the atomic structure. So that is like center part is nucleus, and around the nucleus, all the electrons will be moving. Okay, revolving. Okay, and here this neutron nucleus consists of protons and neutrons, and electrons are revolving around the nucleus. Okay, so that means we can say that particle particle if you a particle made up of molecules, and molecules are made up of atoms. Okay, so these are the different uh, things we need to understand. So what is atomic number? Atomic number is nothing but number of protons and number of electrons in the atom. Okay. So the number of electrons in any orbit is given by 2n square. Okay. Where n is nothing but the number of orbit. So first orbit consists of like 2 into 1 square, 2 electrons. Second orbit consists of 2 into 2 square, that is 8 electrons. Third orbit consists of 2 into 3 square, that is 18 electrons, so on. Okay. So last orbit cannot be have 8 electrons. Okay. Last orbit cannot have more than 18 electrons. So this is nothing but we can call as the number of 8 electrons we call as octet. Okay. Uh, so this is the example of carbon atom. So carbon have protons. In between there is a nucleus. In that nucleus there is a proton, positively charged proton, and a neutron. Neutron have no charge. And around the nucleus, these electrons are moving. Okay. So if you see the structure of element, so here I am taking the example of copper atom. So copper have the atomic weight. So sorry, atomic number. Atomic number is 29, and whereas atomic weight is number of atoms and number of neutrons, number of protons and number of neutrons, that is 64. So if you take the valency, so if you take the valency, so that means so in first orbit there are two electrons, so atomic number two electrons, and second orbit you have 8 electrons, and third orbit you have 18 electrons, and in fourth orbit you have one electron, only one electron. Okay, so only one electron will be there. So that means So it is easy to remove this electron from the nucleus. Okay, from the nucleus. So that's why we can call this copper as a good conductor. Okay, so good conductor. As this electron is moving from this nucleus, the energy of the electron increases, and it is easy to shift this electron from this atomic structure or valence band to conduction band. Okay, that we will discuss. So if you see this, so charge of the electron is, you need to remember what is the electron. That is a tiny particle. Okay, so charge of the electron is 1.6 into 10 power 1.6 into 10 power minus 19 coulomb, and mass of the electron is 9 into 10 power minus 31, and radius of the electron is 1.9 into 10 power minus 15 meters. Okay, so energy of the electron. So there are two types of electron energies are available in the electron. One is kinetic energy, and next one is potential energy. Okay, so total energy we can call as sum of two energies. Okay, so as I told you, know, as the energy of the electron increases, distance from the nucleus also increases. Okay, so we can say that kinetic energy is due to what? Due to motion. Okay, electron will be moved around the nucleus. Okay, so that means kinetic energy is due to motion, and we can say that potential energy. So how the potential energy acquired in the electron, that is due to charge on the nucleus. So that means nucleus will pull the electron. Okay, so there is a charge. That means here in the nucleus there is a positive charge, that is proton, and electron have negative charge. So that means opposite charges attract. Okay, so that means proton. So that means in the proton positive charge, it will attract the electron. Okay, so that's why there is a potential energy. So potential energy is due to charge on the nucleus. Okay, so the proton is attracting the nucleus. So that's why that is due to potential energy. Okay, so we can say that whatever the electron present in the last orbit have higher energy compared to the inner orbit. Okay, so that means log whatever the last orbit is there, we can call as the electron present in the last orbit, we can call as valence electron. Okay, so based on the valence electron, it will determines the physical, chemical, and electrical properties of matter. Okay, so depending on that we can decide whatever the physical properties and chemical properties, and mainly we are discussing here electrical properties of the material. Okay, so valence electron. So what is valence electron? Valence electron is the outermost orbit of the atom, known as valence electron. Okay, so that means based on the conductivity. So that means electron means conductors. These materials are divided into conductors, insulators, and semiconductors. You know. Okay, so that means we need to see like 4 is the reference point in the periodic table. So if you move left towards 4, okay. So if you move left towards 4, okay, left side toward the periodic table, the conductivity increases. So those are nothing but we call as the metals. And if you go right towards from the 4, the conductivity decreases. Those we call as non-metals or insulators. Okay. And 4, whatever the valency 4 is nothing but we call as metalloids, or we can call as semiconductors. Okay. So example, if you see this one, sodium have the valency how much? 1, and magnesium have the valency 2, and aluminum have the valency 3. These are nothing but what? Metals. Okay. So which are having the valency less than 4, we can call as metals. Okay. And valency which are having more than 4 are nothing but we call as non-metals and insulators. So see here nitrogen. Nitrogen have the valency how much? It is having 5, and it is 6, and neon is anywhere inert gas, it is having 8. Okay, so here these are nothing but we call as insulators. Okay, and what are the metalloids or semiconductors? So that means valency is exactly at the 4. Okay, half of the maximum 8 electrons we call as the valency 4. Okay, so example, carbon, silicon, and germanium. So carbon have the valency 4, and silicon also having the valency 4, and germanium also having the valency 4. So if you see the atomic number, silicon have the atomic number 14, and germanium have the atomic number 13. So what are free electrons? Free electrons are nothing but like if you take uh, so if you take some loosely like if you take the copper atom. So copper atom we are cutting into small particles such a way that we are getting to some copper atom. So that copper atoms are there. So when you are not applying any external voltage, so these copper atoms are moving randomly. Okay, copper atoms are moving randomly. There is no flow of current. As you apply external potential difference or external voltage, what happens? There is a movement of copper atoms. Okay, from right to left. Okay, so there is a conventional current that is from left to right. Okay, opposite to the direction of electron movement that we'll discuss. Okay. Uh, So types of material based on electrical conductivity, those are conductors, insulators, and semiconductors. Okay. So that means conductors have large number of free electrons. Let us like copper is there. Okay. So that means if you apply small amount of energy or like in terms of heat or supply voltage, it will form a electricity. Okay. Insulators are nothing but there is no free electrons at the ordinary temperature. Semiconductors are nothing but few electrons are there at room temperature. Under the influence of potential difference, semiconductor practically conduct no current. Okay. So before going to this semiconductor series, we need to know about Bohr's atomic model. Bohr is a scientist here. In 1913, he is a Danish physicist. So he clearly explained the atomic structure of atomic structure. So explain that like a solar system. So sun around the sun, the planets are moving around the sun. Like that, same like that, nucleus around the nucleus, electron is moving. Okay. So these are some four rules. The Bohr atomic model. He given the rules. An atom consists of positively charged nucleus around which negatively charged electron revolve in different circular orbits. Okay. So that means atom is having positively charged nucleus. That means in nucleus, what will be there? Protons and neutrons will be there, and that's why we call as protons have positive charge. That's why positively charged nucleus. Around this, electrons will be revolving around the nucleus in which orbit? Circular orbit. Okay, and electrons can revolve around the nucleus only in certain permitted orbit. Okay, so there are certain permitted orbit are there. We call as radii. Okay, at certain permitted orbit that will move. Okay, so at certain permitted orbit they have the fixed amount of energy. So larger is the orbit, that means greater is the energy of the electron. As I told you, know, as the electrons move away from the orbit, the energy of the electron will increase. Okay. So for this electron, if you give additional energy, like in terms of heat or light or some external electric field, so we can lift this electron to the higher orbit. Okay, we can call this as a state of excitation. It will excite or it will jump from valence band to conduction band. Okay, valence band to conduction band, and this state will not last one longer. So after some time, it will fall back to original lower orbit. That means it will be fall back to its atomic structure. Okay. So if you say the example of carbon atom, so what is the valency of carbon atom? 14. So sorry, what is the atomic number of carbon atom? 14. So that means in first orbit, 2 electrons are there. In second orbit, 8 electrons are there. In outermost orbit, how many electrons are there? 4 electrons are there. So that means we can say that first orbit is K shell, and second orbit is L shell, and third orbit is M shell. So these are available in terms of radii. Okay, these are, as I told you, know, these are revolving in terms of different radii. Okay, so each orbit have a fixed amount of energy. Okay, so that means so we can represent this energy in different orbits. So energy in different orbit, like at radii one first energy level, radii two second energy level, radii three third energy level. So we can call this as energy level. So this is related to what? Only one carbon atom. Okay. So one carbon atom we can represent in terms of energy level. Suppose if you take any compound or any matter, so carbon atom is again you have group of carbon atoms which are covalent bond. By sharing of electrons, some millions of carbon atoms are there. Group of carbon atoms are there. So if you take the group of carbon atoms, we define this energy levels in terms of what? Energy band. Okay. So we can define energy level in terms of what? Energy band. Okay. So that means range of energies possessed by electron in solid is known as energy band. Okay. So that means if you take the energy bands, those are nothing but two types. One is valence band and conduction band. Okay. So valence band is nothing but what the range of energies that band possesses electrons is known as valence band. That means whatever the electrons present associated with the atomic structure. Okay. Associated. The electrons are present in the atomic structure. That is nothing but what valence band. Okay, and conduction band is nothing but what? So when conduction band means, suppose if you take carbon atom, in valence band only one electron is there. So if you apply some external heat or external potential difference or external voltage, okay, or external light, it will jump from, so it will become free and it will jump from valence band to conduction band, and so that we can use that copper atom as conductor. Okay, so that means when it is means when it is jumping from valence band to conduction band, the electron becomes free. Okay, so this is responsible for the conduction. When the electron present in the conduction band, that is responsible for the conduction. Okay, so, and what is forbidden energy gap? The separation between conduction band and valence band on the energy level is nothing but forbidden energy gap. Okay, the distance between. So electron may contains in valence band or it may contains in conduction band, but electron cannot be available in between this forbidden energy band. Okay, the distance between this distance is nothing but we call as no electron of the solid can stay in the forbidden energy band. Okay, that you need to remember. Okay, so this is about atomic structure. I think you understood this. Uh, so thank you very much.